Welcome to everyone. After complete of group theory, we move to next chapters, that is physical spectra. Physical spectra. In this chapters, we will discuss three spectroscopy. One is rotational spectroscopy, and second one we will discuss vibrational spectroscopy, and third we will discuss about Raman spectroscopy. So let's start with rotational spectroscopy. So rotational spectroscopy. So if you talk about any spectroscopy, it means spectroscopy means that interactions of electromagnetic radiations with matter. It means interactions of electromagnetic radiations with matter. And in the rotational spectroscopy, it means that if you rotate a molecules, then what the spectra will get means rotations of the molecules that we studied in spectroscopy, then we call that is rotational spectroscopy. So here that to rotate a molecules, the microwave is enough to rotate a molecule. So we will use here that microwave radiations. So microwave is used as a radiations, and the sample is in gaseous form. So sample we will talk that samples are to do a spectroscopy, to study spectroscopy. Some samples we need to take, and the sample has to be in the gaseous form or in gaseous phase. That should not be in the liquid or solid, because solid and liquid the intermolecular distance is very high, so the microwave not able to interact. So we will take either gaseous phase or gaseous form only we have to take, no solid or no liquid form. Okay, so sample has to be gaseous form. And one more important point is that the molecules which are studying rotational spectroscopy, that has to be a dipole moments. The permanent dipole moment should be present in the molecule. So dipole moment should be present in the molecule. So if I talk about let's a little bit discuss about dipole moment. So dipole moment, if we say what you say that dipole moments, that if you the mathematically dipole moment is expressed as q into reduce the distance between two molecules. Let's say if I take any molecules, let's say A to B, and let's say A and this molecule is polar, then only that dipole moment will be there. So A and B has to be A and B has different electronegativity, has a different electronegative. That means if B is if B has high electronegativity, then I put negative, delta negative, and this is delta positive. So this is a polar molecule. Polar molecule means where charges is there. So if charges is there, then only the this dipole movement, this dipole will be created. So this how will you express this, that positive to negative. So you will put like this. Okay, this is the arrow of dipole moment. So if I say that here that q and r are fixed, this is the q distance between the two molecules and q is the charges, so this is safe. So another is that dipole moment is a vector quantity. It is a vector quantity. So if it is a vector quantity, then vector means what you know, that it has both directions and the magnitude. So directions and magnitude both we have to consider. So if I say that here that AB molecules, the charge and the radius is fixed. So here we are talking about of the rotational molecules. So rotational spectroscopy means we will use that microwave, means that microwave we are giving to rotate the molecules. So after rotation of molecules, whether dipole moment is changing or not. Okay, so let's look. So let's say this A molecules and B molecules, and this is high electronegativity, this is low negativity. So this is change like this dipole moment directions. Okay, now I am giving that electromagnetic radiations, that's I am giving the microwave radiations I am giving. After giving that microwave radiations, what happens, this molecule will rotate. So to rotate molecules, we are giving that microwave. Means whenever you are adding sample to spectroscopy, then what that it's in the spectroscopy, microwave is there. That microwave will rotate the molecules and will check that what is the sample it is. Okay, so that's what is happened. So if I give the microwave, then this molecule will rotate. So this rotation will happen. So if it is rotated, then let's say B go here and A come here. So this is negative, this is positive. So directions now is like this direction. So sorry, positive to negative. So this direction is like this. Again it will rotate. Let's say then now it will be here like this. B here, A here. This is delta minus and this is delta positive. So sorry. And now the directions is like this. So we see that after rotating a molecules, the directions is changing, and since it is a dipole moment is a vector quantity, so if the directions is changing, then dipole moment is changing. Yes, so because here q and r are fixed, but the direction is changing, and since dipole moment is a vector quantity, so if any one is change, directions or magnitude, any one will change, then dipole moment will change. So here the dipole moment is changing. So actually what happened, that whenever we are giving that microwave radiations, and it always not accept these radiations. If the molecules is changing, if the molecule, first the molecule should have that dipole moments, and when this accept this microwave, only that this microwave radiations or the frequency whatever we are giving, that frequency should be matched with the change in dipole moment frequency. Means this molecule is rotating, so due to rotation the frequency will be there. So that frequency and this frequency whenever match, then only this molecule will observe this microwave frequency, and the molecule start rotating more. So for now it is rotating like this. So this rotating, let's say first time it rotating slowly, and whenever we give the microwave radiations, then if this microwave radiations is matched with the change in dipole moment frequency, this microwave frequency and this changing movement of molecule, so due to change in movement of the molecule, so frequency is there. If that frequency and this microwave frequency is met, then this molecule observe this frequency and the molecules will rotate fast compared to previous one. So what we say here, that molecules molecules have dipole moment have its frequency, and we are giving electromagnetic radiations or I can say frequency. We are giving frequency of electromagnetic radiations, so means that we are giving that microwave. And when frequency of dipole moments, that is change in dipole moments, so due to change that frequency is creating such frequency of change in dipole moments match with frequency of electromagnetic radiations the molecules observe the radiations and rotate past. But if radiations of electromagnetic radiations, or if frequency of electromagnetic radiations is not match with frequency of electromagnetic radiation is not match with frequency of change in dipole moment, the molecule not observe that frequency. It means what we understand that the molecules observe certain amount of frequency only. If the frequency, if it is matched with its frequency, then only the molecules will observe. Means it observes some certain amount of frequency only. So you say that, let's say if a molecule is here, molecule is rotating at this energy, let's say U1, and you are giving that any electromagnetic radiations, then the molecules observe these radiations only if this energy match with the change in dipole moment, frequency of change in dipole moments, then only it will observe and it will shift to the higher energy. Let's say this molecule, this will shift only if this electromagnetic frequency of electromagnetic radiation is matched with the frequency of the movement of the molecules only. So that energy is quantized, that we will study while we proceed the chapters. So now one thing also to discuss, that molecules is rotate. So molecules rotate in a four ways. So according to that, the molecules we classified into four types. So before we proceed about of that four types of categories of molecules, we need to know that about of the inertia, movement of inertia. So let's say that we know that momentum, linear momentum, we know What do you mean by linear momentum? That we explain as P, that is equal to mass into velocity. And similarly we know that angular momentum, that is the moment of inertia into, this is velocity and this is angular velocity. Angular velocity, and this is mass, and this is the moment of inertia. So if you look these two terms, that linear momentum and angular momentum, so this is velocity, this is angular velocity, this is mass, and this is moment of inertia. So if you look both this, then this moment of inertia somehow related with the mass, because linear momentum is mass into velocity and angular momentum is moment of inertia into angular velocity. So since this is velocity, and this is mass, then this is also has to be some relations with mass. Okay, so this moment of inertia is important for this chapter. So if I talk about a moment of inertia, that is I. So this moment of inertia, we can say that that force or that torque required, the amount of torque means that amount of force required to rotate a molecule. So the amount of torque required to rotate the molecule. So this moment of inertia somehow related with the mass, because this angular velocity and linear velocities are interrelated, and this is mass and this is velocity, this is angular velocity, and this is moment of inertia. So this equal to this, then this also somehow related with mass. So this amount of torque, so moment of inertia if you define, then amount of torque required to rotate the molecule, it means some amount of force, and force equal to mass and accelerations. So this moment of inertia somehow related with the mass. So this moment of inertia I is generally, that is mass into that is any r square. Means this is sorry, I can simply say mass into r square. So this is m represent the mass and r represent the distance between I can say the distance between the molecule and center of gravity. Molecule and center of gravity. So now that come that what do you mean by center of gravity? Okay, so if I talk about of that, let's say one molecules here, this is rotating. So this, if you rotate it, let's say if I have one rock, okay, this is one of my rock. So if I am rotating these molecules, then it will, I rotate like this, then that it rotate at some points with that center it will rotate. So this is known as the center of mass, sorry, center of gravity, and this distance is called this r. Okay, this is the distance, this is the molecules, and this is the center of gravity. So this r is distance between molecules and center of gravity, and the mass is the mass of this molecules, mass of the molecule. Okay, so if the molecules are two, let's say now we are having two molecules, then let's say molecules. So here where will the center of gravity will lie? So the center of gravity will lie somewhere that like if you are taking, if you may look somehow that what you say that when like you say that which example I say okay, so that examples we will take later. So if the two molecules are there, then center of gravity will lie at the yes. If you take that, if you rotating one molecule, or if you rotate any molecule, that rotate at the points where that the molecules will rotate with considering that some points. So if I say about of it, then in between that somewhere that the mass is equal, so that on that point these two molecules will rotate, means with respect to that point these two molecules will rotate. So that is known as the center of gravity. And if one molecule is smaller and one molecule is greater, then center of gravity will lie towards this heavier molecules, means like this. Okay, so according to means with respect to this point these molecules will rotate. This is known as center of gravity. If the two molecules have different mass, then the mass having that higher that side, that center of gravity will lie. Okay, and what we say that the center of gravity here at this point, let's say this is m1 mass, this is m2 mass, and distance between this is, let's say, r2, and distance between this is r1. And at this point at the center of gravity, let's say at center of gravity m1 r1 has to be m2 r2, means at this point this and this multiplication of f1 and r1 equal to m2 r2 at center of gravity. This is the foremost conditions for the center of gravity. Okay, so let's say why it is lying towards the heavier molecules. Let's say this is have the mass m2 and this is have the mass m1, and we know that m2 is greater than m1. So here it reduces r2, let's say here reduces r1, and this is, let's say, r2. So at center of gravity, but you know that this m1 equal to r1, m1 into r1 has to be m2 equal to r2. So if this is more, let's say m2 is greater than m1, then this r2 has to be, so if it which lies, if r2 and r1 is equal, let's say if the center of gravity is somewhere here, then what the problem, that if r1 equal to r2, then since m2 is greater than m1, then this will be unequal. Let's say this is that. So if I say center of gravity, means that m1 r1 has to be m2 r2, but since that m2 is greater than m1, so r2 should be smaller, because m2 is greater, so this greater and this smaller will be equal to m1 into r1. That's why this is lies towards the heavier molecules. Okay, so we will discuss in the next class about that due to molecules it will rotate in different ways. So according to that we classify the molecules in 4 types. That we will discuss in the next class. So today up to this, thank you.